right. Well, it is noon. You have made it.
Yeah.
All right. So what we want to do, I want to do this sort of fast because I want Mr. Mike to join. I'm going to share my screen.
Wait, can I ask a question first before we start?
Yeah.
Emma, why did you create a worksheet for the class?
Oh, well, you're about to find out.
Because my mom asked me to,
Oh,
and I am an
Hey.
obedient child.
She's so kind. All right. We're going to watch
yay,
a couple
rockets.
rockets for our rocket class today because after I read the chapter, it was
Dang
on
it.
Newton's second law
I
and third law, and I went, we got to do rockets, man. That
thank
is.
thank you, Mr. I have the Miles from Tomorrowland theme stuck in my head now.
So we are going to watch some videos, and hopefully by that time, Mr. Mike can join us. And we're going to get doing some rocket science. We're going to have two teams.
Boys versus girls.
Well, it kind of randomly,
Oh.
I'd have to piece everybody in that kind of randomly put y'alls into teams. All right, who's ready for rocket class?
Me.
Me.
I hear one me. Oh, okay, two me.
Me.
All right. Well, at least we got three. Three's company. All right. We're gonna go ahead and start, and then we'll just, as people join, they're just gonna be in the middle of a video. All right. Now, one of these we have seen before, but I'm gonna play a couple minutes of each one. Just to kind of get us excited. Now, what we're going to show two videos. The first one is the Starship, and the second one is Falcon Heavy. Those are the two rockets that we're going to be mathematically calculating.
Wait, the giant Mars rocket?
That's right. Yeah.
Yeah, I think completed a successful test launch last year, I think.
That's right.
This is the final go, no go poll for Flight 3 of Starship. Avi 2.
Go.
Stage 1.
Go.
Stage 2.
Go.
Flight director is go for launch. We have liftoff.
Vehicles pitching downrange. Max Q. Vehicle supersonic. Stage separation.
Okay. That's how far we're going to get in each one. We're going to be launching the Starship. There's going to be a team Starship. And we're going to get to the first stage of each one. All right. So second team, and you don't know what team you're going to be on, so pay attention. Second team is going to be Falcon Heavy. And we're going to watch the first part of that. Well, we might watch the whole thing. Will depend. Let's see. So that's it going up. Let's see if I can get to where it actually launches. Here we go. I don't hear sound on this one. Do you guys hear sound?
Yeah,
No.
I can't hear sound.
Okay.
me.
Yeah, for some reason I don't hear sound on it. That's okay. We've actually seen this before. This is the one that puts the car in space.
Mm.
We've watched it before. All right, so this is the Falcon Heavy one. All right, notice the difference between the two, all right? You have the 3 rockets on there.
The other day I saw an electric Porsche that had a license plate that said "Sorry, Elon."
That's funny. And this is where the first stage of the rocket, the 2 on the side actually come off the boosters and then they come back to Earth. You see the speed there? We're actually going to be calculating that. And they separate. Okay, so we've seen that one before. So it's not just, let's see if I can put it in. There we go. It's not rocket science. Oh, wait. Yes, it is. So, you guys ever heard that phrase? It's not rocket science.
No.
Yep.
Yeah.
Does it mean that it's easy or hard?
It's easy. Depends on the person.
That's true.
Yeah.
But
It's not
generally,
rocket science
everything
means
is
it's
because
easy.
rocket science is hard. I
Yeah.
love to show this picture about how hard it is. This is a very old picture. This is Margaret Hamilton, and she was a software engineer for NASA. So this stack is all of the code needed to get to the moon. This was
Wow.
our project. So that's how much math and coding you're going to need, guys.
What's hilarious is now that we have our smartphones are now more powerful than the computer that shot up Saturn V, which
Great. Right,
No,
which
no,
is
no,
why
no, no. It's not
is
even.
ridiculous.
It's not even that. The calculators we have are more powerful than that. The dinky
Yeah.
little cheap calculators are more powerful than that.
that's right. And speaking of how much more powerful it is, so Katherine Johnson was actually an amazing physicist and mathematician, and she by hand calculated the flight trajectories, which we actually still use today. But when NASA actually switched to computers, they would still call on her because they didn't trust the computer's math. So that's how bad the computers were back then, right? But she
Yeah,
at
that's how good she was.
age 10, guys, she graduated high school, and at 18 graduated college. So when most people were going to college, she was graduating from it, and she got a degree in mathematics. So pretty cool. All right, so today we're going to be launching 2 rockets, Starship and Falcon Heavy. Let's see if I can leave my computer here. All right, here we go. All right, so we have Starship and Falcon Heavy. All right, so before we get into our teams, let's kind of look at the schematics, both of them, just so we understand the lingo. So when we say stage 1, what is stage 1? Does anyone know?
Liftoff.
Lift off.
Sure, where did stage 1 end?
At low orbit.
Okay, so basically these are going to come off, right? So this holds all of our fuel. What will be said is propellant. This is going to hold all the propellant. When the propellant runs out, then it disconnects and then you turn to stage 2 engine. Okay, so we're just going to be calculating some math in stage 1. All right, so same with Starship right here. This would be stage 1. So this is actually called Starship. Okay, this is Super Heavy. That's what the rocket is called. The rocket is called Super Heavy. And this is on top of this rocket, Starship is. Okay, or it's sort of like up here. Here's the payload on that one. Okay. All right, so here are 2 teams. You don't get to pick, I'm sorry. All right. Okay, some other lingo, like I was saying, this is the propellant, so it'll be named propellant instead of fuel. You're gonna have some charts. We'll have like here Falcon 9, it'll use a liquid fuel, and we'll have a 1D Merlin rocket. Actually, I kind of want to show you guys that. Let's see if I have. Here we go. All right, so hopefully you guys will be able to get to the internet. I'm hoping your parents would allow you to do that, because we're going to gather some information from SpaceX and also a little from Wikipedia. Okay.
I've already reviewed this website like 3 times.
You did?
For fun.
Oh, nice. All right. So you can navigate through it for your team. All right,
Wait.
so let's look at Falcon
Need
Heavy.
some paper.
You need some paper, go get some paper. All right, so Falcon Heavy. So as you see, there's 27 Merlin engines here. Here we go. So you'll be looking at these stats. Here's the overview. The mass, what's the mass, guys?
3,125,735
All
or
right, so
one
we'll be
million four
using,
hundred twenty 788 kilograms.
right, so we will be using the kilograms, right?
Do we need a
Um,
calculator?
Oh, yeah.
Oh yeah.
I'm gonna get one.
Okay. Okay. So here's our first stage, all right? Let's see. Here's our engines for if you were on Team Falcon Heavy. Okay, you notice the two thrusts. Why do they have a thrust at sea level and a thrust in a vacuum?
Space must be the vacuum, right?
There you go. Does everybody understand that?
Yeah.
One's for calculation when you get into space in orbit, right? And the other one is here on Earth at sea level. Okay, cool. All right, let's see. Let's do another one. Let's do Starship, just so we're very familiar with what these things are going to say. Here's our overview. So as you see, this is called stacked or fully stacked. So the rocket is underneath, it's the silver part, right? That's our super heavy. And then Starship is on top. So here's our Starship. It's going to give you, there is some propellant in that. It's going to give you thrust and how much payload is how much it can carry. Okay, which is going to be important if you want to go to the moon and Mars, you want to actually bring stuff, right? All right, so go back. All right, super heavy. Here's the rocket part. All right, so it can hold propellant. It can hold about 3,400 tons of propellant. Now, you can use a online converter if you like, but I would say to put tons into kilograms, you just multiply by 1,000. That would work as well. All right, and it uses Raptor engines. All righty. So let's continue. All right. So this is what we sort of learned in our lesson 7. All right, so force equals mass times acceleration. All right, so how we're going to relate this to rockets is the best way I can say it is by units. So here we have force is going to be in newtons, and that is going to be equal to kilograms times meters over seconds squared. That is always going to be newtons, right? Or what we're going to calculate for newtons. All right. So in a rocket, thrust, instead of force, we're going to use thrust, okay? And instead of the mass, we're going to do the mass flow rate of your, whatever your propellant is, okay? And instead of acceleration, we're going to do the exhaust, so the velocity of the exhaust. So here are the 2 units that you'll use here, and I would write these down. So kilograms per second times meters per second also equals kilograms times meters per second squared, right? So these 2 multiplied together would also give you newtons, which is why there's your thrust in newtons, okay? And that's for the fuel. So that's for the engine part of this rocket. Now, if you would like to know how fast this rocket is going to accelerate, we can rearrange this equation to acceleration equals thrust over the total mass of the rocket in kilograms. So as soon as you know this thrust, right, you can actually divide it by the total mass. How heavy is that rocket? And you
Yeah,
can tell me
I
how
didn't
much.
get how heavy it was.
That's right. Right. No, well, I will here in a second. It's an example question. And then you can tell me the acceleration. Okay, now what you should write down is acceleration units will be in meters per second squared. And everybody knows that because what's the acceleration due to gravity?
9.8
9.1 meters per
meters per
second
second
squared.
squared.
Jinx.
There you go. So you already know acceleration is in meters per second squared. Your velocity will be in meters per second, right? And your flow rate here, which we'll use, I'll kind of explain more in a second, is going to be kilograms per second. All right. So let's keep going. Let's do our first problem. This is going to be easy peasy for I think once you guys get the gist of it, it's going to be super easy. Okay, so we have a rocket that's 850 kilograms. All right, and that's the initial mass of this rocket. It consumes fuel at a rate of this. So here's our units, kilograms. Here, I don't know why I'm writing in blue. Kilograms per second. All right, 2.3. That's the rate, the mass flow rate of what it's consuming fuel. Here's its exhaust. Now, sometimes I did put this in here. It's V escape. So sometimes that's the escape velocity of that gas. All right. And of course, it escapes at 2,800 meters a second. All right. So what would be, the question is, what is the thrust? What would we have to do to get kilograms times meters per second squared? Because this is in newtons, right? So what would we have to do to those two?
I don't know.
Anybody know?
I don't know how many newtons are in kilograms.
Multiply the fuel consumption rate by the speed of the exhaust gas.
Perfect. Super easy, right?
So multiply or divide.
I was writing down.
Right. So this is just
I
our
don't
F
know.
equals, this is just our
Numbers.
F equals ma equation, guys. Okay. So instead of F, we're doing thrust. Okay. Same units, newtons. So, and when we multiply these units together, we'll get kilograms times meters per per second, newton per second squared. All right. So who can do this on their calculator? What's the total thrust that we will get from this?
2.3. Okay, let's see.
Wait, let me.
How many newtons?
6,440.
Yeah, that's what I got as well.
Yeah, that's what I got.
6,440.
See, this is easy. It's not hard. All right. So that's how much thrust is going to come out of that engine. Okay.
It is rocket science.
So my question is, second question, what is the initial acceleration that's in meters per second squared, right?
Well, for
Of
the
the rocket.
for
So
the thrust, I got 1955.
all right, well, it's 6,440 newtons. All right, so acceleration is going to be the thrust that we just calculated over the total mass, right?
The mass is 850 kilograms.
All righty. So what's that equal? What is our acceleration, our initial
Wait.
acceleration?
I think I did it wrong.
7.5.
6.4.
7.5.
I think I did it
It's-
wrong.
It's
7.5.
6,440, not 6,400.
Oh, sorry. Did everyone get 7.5?
So is
Yeah, I
it
got
supposed to be-
7.5.
All
Is it-
right, meters a second. All right. So the question I have for you guys, looking at the initial acceleration, will this rocket lift off the ground?
Maybe.
No,
No.
Why will it not lift off the ground?
because the
Because
it is
acceleration
less
due to
thrust.
gravity is
9.8.
9.8, and that does
It
not meet the
that's right.
acceleration required.
Yeah.
Mhm.
All right.
It sucks.
So I'll do
At
you
most, it would probably get like 4 feet off the ground.
So
And
this
then
is why
explode.
this is
And
why
then
Horrible,
people so
horrible
explode.
fire.
they just use it to not get rockets off the ground.
All right. So what does the thrust have to be in order to get this 850 kilogram rocket off the ground?
More.
9.8.1.
9.8.
Oh, it's 850.
9.81.
9.82.
That's right.
It
What does
has
it
to
have
be.
to be?
It's bigger than 9.8.
What is it?
83,300.
What do you say?
83,300.
That's how
It's not
many newtons.
83,000. It's 8,330.
That's right.
Yep, 8,330.
That's how many newtons you need to get this 850-kilogram rocket off the ground. Okay?
That's a
Now I
lot.
can finally brag to my friends. It's just rocket science.
Yeah.
All right. Let's continue. All right. So now we have a problem because we have a change in mass. What do I mean? Why do we have a change in mass, everybody?
We lose
If it's
fuel.
the Falcon, the fuel tanks dropped off. If this is the Falcon Heavy, then the two fuel
Booster
providers on the
rockets. Booster
side.
rockets.
Yeah.
Or you're
So
just losing
as you,
fuel.
that's right. You're losing fuel. You're losing weight as you go up. Okay. So it gets a little more complicated than F equals ma, doesn't it? With change in mass, we also have change in velocity. Okay. So we're going to do some calculus. I would
Oh,
like
no.
you guys to write this down just to be familiar with it if you haven't done calculus. But you can watch if you'd like, and we're going to actually just use the end answer. This is the creme de la creme ideal rocket equation. Okay. All right.
This is not the real world rocket equation.
Yeah. Well, yes. Okay. So this is actually easier than we think. It's going to look complicated, but I think you guys are so smart, you're going to get it. Okay. So what we're going to say is the change in mass. So what we're saying is there is some initial mass, and we're trying to find, and it's going to go to some final mass, and we're trying to find the change in velocity. Does everyone know what this triangle means?
Delta.
That's a D.
That's delta. That just means change, right? The change in velocity. All right. So we're going to measure this by something called impulse. All right. Now, what is impulse, Miss Tara? That's such a great question, guys. All right. First, we have two different impulses. So let's say we have the impulse of the rocket. Okay.
Miss
And
Tara,
that would be equal to, yes,
what did you want me to write down?
you can write all of this down.
Okay.
Or at the very end, there's an equation we're going to use. So the first half, there's an impulse of the rocket. All that means is it's the mass of the rocket times the change in its velocity. Okay, super easy. There's another impulse. That's the engine, right? That's the stuff coming out because one's going this way, one's going this way. All right, so the impulse of the gas is going to be equal to the mass times the change in, no, it's not. Wrong. Okay, it's going to be the escape velocity times the change in mass. Okay, so we sort of talked about escape velocity in that last example. All right, now notice I'm not using triangles anymore, right? I'm just using this D for delta. When you're switching to calculus, you'll start doing that. All right. All righty. So these are going to be equal to each other. They're going to be equal to each other because of something that you guys read about in your chapter. Conservation of what, guys?
Momentum.
Energy.
That's right. You had a whole chapter on this. Conservation of momentum. So this is going to be, let's see, this is going to be equal to this. So we're going to set that together and actually do our math. And that's it. All right. So we're going to say mdv is going to be equal to the escape velocity times the change in its mass. All righty. Now they go in opposite directions. I'm going to put a negative here. We're not going to get into vector mathematics today, but we're going to put that there. Oh, there was an aw. Does somebody want
No.
This makes me many sads.
I know it does.
Mr. Mike.
Hi,
sure-
Dad.
Hey, everybody.
Yeah, he's here. Okay, Mr. Mike's here to correct all my mistakes, guys.
Now it's Mr. Mike's turn to teach.
We learn through making mistakes, isn't that
We
right?
do. Yes, you're right. We do.
It's called
Okay,
discovery.
so what we're trying to find is this, the change in velocity, this right here. Okay, so we need to get this by itself, which means we have to do what? How do we
Divided
get
by
that?
m, divided by n, divided by m.
Easy peasy. You guys know this. Change it up.
Oh,
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 okay, good.
oh,
Oh, no. Okay.
oh.
Okay. I thought it erased everything. I was about to be so mad. All right. dv equals v escape. All right. And now we're going to do this 1 over m dm. Okay. Now this is where calculus comes in. Okay. So I want everybody to try to write this just to get used to this. It's like a fun little squiggly, right? Does anyone know what the fun little squiggly in calculus is?
Oh,
No.
What's that called?
the
Equilibrium.
Oh, the end
Oh,
of
so-
engineers and the beginning of business majors.
Okay. That's called an integral.
integral.
And we're going to set some limits
Oh,
there.
my
All right. So we're going to put that in. Oops. Let's write that a little better. All right. And then we're going to say the integral from the first mass to the final mass, 1 over m dm. All right. So there's our calculus, guys. Okay. And that is, this is called deriving the equation. All right. We're not really going to get into more than that, but this is what it's going to look like. Okay. All right. And what this means is there's essentially some final velocity minus some initial velocity. Okay. And that's going to be equal to, the best way I'm going to say this is there's a rule in calculus called the reciprocal rule. And
I have
it's
to go
going
for
to
a
change.
second.
It's going to change what this looks like. Okay. And it's going to look like this ln. Who knows what ln stands for?
Natural log.
Yep. Natural log. All right. So that's what it changes to. And we're done with the calculus. We're just going to clean this up. All right. So we're going to bring this back to delta V. Okay. And we're going to say V escape. And we're going to say ln initial mass over final mass. And that's it. That is the rocket equation without getting too much up to the y, the calculus y. But that's what we're going to be using today. This is the creme de la creme, delta V. Everything you're going to need to know is everything in rocket science. Okay. If you want to know how to get into orbit, how to get out of orbit, change orbits, go to the moon, you need this equation. Okay. So in a lot of movies and stuff, sometimes you'll hear the scientists go delta V, you know. And now you know what that means. Okay. So it's just the change in velocity with the change in what?
Velocity?
Mass.
Right.
Mass.
We're losing
Mass.
fuel. We're losing the fuel. Okay. So we're going to be
Dude,
using
this scares me for
equation. So does
calculus,
everyone
Mr. Ra.
have this? Say that again, Levi.
This scares me for calculus in the future, Miss Sarah.
This is gonna
Nah,
be spicy. I'm gonna enjoy this.
No, you put the
This
little
is
squiggly line there,
Juicy.
and you said that's not even the end. I'm like, huh.
But wait, there's more.
Mr. Mike, do you have something else to say about integral? Like that's easy, right?
Do you have an opinion, sir?
Yes.
Oh, okay. What's your opinion?
The sooner you can be introduced to this and understand what all these squiggly symbols and stuff mean mathematically, the better off you're going to be if you pursue a career that requires this.
If.
Mr.
If.
Mike,
I
Mr.
think I
Mike,
would-
how much harder is calculus and algebra?
Exponentially.
Ha ha ha. Very funny.
Gee, I can't wait to do calculus. Just kidding.
Oh,
right.
oh me, oh my. Oh,
So
dear,
I
oh,
do
dear,
have
oh
a
God.
question. Knowing this, I do have a question moving on. Why is it important that we have a multi-stage rocket? So we learned that there's a stage 1 and there's a stage 2. Sometimes there's a stage 3. Why
It's
would that be
Because
important?
those
It's
things on the
important.
side are heavy.
Hey,
Does
Evan,
it
I
need
see.
to be in case that like the thing in the middle doesn't burn on its way out?
Evan, I see
But
you got
you
your
don't need
hand
as
up,
much
bud.
fuel.
Go ahead.
Yes. Go ahead, Evan.
I think this team might be a little hard for me.
Well, guess what? It's a team effort. So even if
Right.
it's difficult now, that's okay because there's no grades, there's nothing going on. This is just for fun and you don't have to know it today. This is just learning all about it and your teammates will help you with it, okay? All right,
So that
so
it's easier for later.
that's right. You don't have to know this now, but later on when you see this, you go, "Oh yeah, I remember seeing those symbols in Miss Tara's class. I remember her saying it's not super hard." All right, so I think I heard something about the multi-stage rocket thing. So essentially, it would be important because, well, wouldn't you want to drop some mass to go faster? Right? So as you're using the fuel, would you rather have mass of empty tanks going with you?
No.
No, you can drop those, right? Because it's directly going to affect your velocity, isn't it?
And you need less fuel in space.
You do need less fuel in space. That's right. Why would you need less fuel in space?
No gravity.
Because there's
You're
less
just
gravity affecting
floating.
you.
Well, there's less friction, right? Yeah, true. Less. And inertia. Once it starts
Inertia.
That's right. Once you start moving, you don't need a lot of anything else to get. All right, so this is what you guys did. So this is college level, right? So Evan, you should feel happy. This is college stuff, right? This is the ideal rocket equation with NASA. Essentially, we did this. Now, why I'm showing you this is because when you guys are going to be inputting some numbers, I found this very useful. Okay, so they used a VEQ. So instead of the velocity escape, they called it the equivalent engine exhaust velocity. Okay, so you might see a little differences, but it's going to be equal to this. That's called the specific impulse. Okay. And we're going to see where we're going to find that because they don't give you the escape velocity. They give you specific impulse. Okay. Oh, this is a fun thing. This is who speaks Russian?
Not me.
No.
I dabble.
Nobody wants to pronounce this guy's name?
Konstantin
Konstantin.
Tsiolkovsky.
Konstantin
It's Konstantin
Konstantin
Tsiolkovsky.
Tsiolkovsky.
Yeah,
Is
that's
he
the
German
guy
or
who
something?
made this equation.
No, he's Russian.
Tsiolkovsky.
Anybody
This
that has
is-
a last name like that is Russian.
The Russian rocket scientist that invented this equation. Okay. All right. Let's see. Oh, here's our reciprocal rule here. We did. So you guys should feel very proud of yourself. I do like this part where it's actually knowing your limits of the full mass and empty mass. All right. So here is what we're going to do because I don't want to muddy the water too much. Okay. I'm going to put you in 2 different teams and I'm going to show you where to go for this information. So you're not super lost. Okay. But there are 3 questions your team is going to have to answer. One is how much thrust is needed to lift off the ground? That should be super easy. And I gave you the equation, T equals MA, right? Now, to lift off the ground, well, you know the acceleration, right? Needed to lift off the ground. So really, you just need to know the mass of whatever team's rocket you're on, okay? The second question is going to be with max thrust. Now, they will give you that answer. Okay, you can find the max thrust of Starship and Falcon Heavy. Okay, and so knowing that, what would be the acceleration at the end of the first stage? Why would I put that? What does that change for mass? What happens at the end of the first stage with mass?
You
It decreases.
Have no fuel left.
You
You
have
have
no
no fuel left in your
So
in your
you are
first
going to
stage.
have to find the weight of the propellant and subtract it from the total mass, the original mass. Okay. The third question after that is I need to know how fast it's going. This is our delta V, right? This is how fast is the rocket traveling at the end of that first stage. Okay, so it right after it dumps all its fuel, how fast is it going, right? You will find a specific impulse, and then you will put in your initial mass and your final mass, okay? So obviously one's going to be with fuel and one's going to be without the fuel, okay? Now let me show you where you can find this. All right, here is Wikipedia. I found this to be the best source. Now you can go to SpaceX if you'd like. It's up to you and your team. But here's an example on Wikipedia. Here's Falcon Heavy. All right. If you look on the right table here, it will actually give you, like, it'll say the total mass in tons. So you just multiply that by 1,000. All right. We'll give you kilograms. It'll also go down first stage. So you're going to be getting a lot of your information under what's called the first stage. So you see on the right there for the table. And do you guys see in blue specific impulse?
Mm-hmm.
Okay. Now, are you going to be using sea level or vacuum?
Sea level.
For the first stage, sea level.
All right. And you're probably also going to be using the kilometers per second. Okay. All right. Now, on Falcon Heavy team, you're going to have to go a little bit farther to get the rocket specifications on maybe the mass of the fuel, the mass of the propellant. Okay. You see the tank capacity it has, the fueled mass there. So those are some of the things you're going to be looking for. If you're on the Starship team, they have it all on the right side here. You have the initial mass of the rocket, which is, what's the mass of Starship, guys? Under size.
5,000 tons.
5,000 tons. So 5 million kilograms. All right. And you're going to go to the first stage. It gives you, powered by 33 Raptor engines. It gives you specific impulse. It also gives you max thrust. Okay. So these are the things that you'll be looking for. All right, let's see. I'm going to stop sharing my screen and you get a lifeline. Everybody gets Mr. Mike to help them.
Oh.
Dun, dun, dun.
Mr. Are you gonna be leaving?
That's why I was trying to do the class kind of fast. Like,
No, I don't want to
we
be left
keep
with
this an
Mr.
hour.
Serious. I'm just kidding.
All right, let's see.
Oh.
We're going to call this, instead of Runa, we're going to call it Starship. Yes, and we're going to call the second room Falcon Heavy. All right,
You
looks like
on
we
the
have
other side.
9 and 7. It
Talking.
looks- Is everybody rocket scientists? Are you geniuses at this?
No.
We
No.
were so close.
We almost
We were
had it.
so close.
Sorry,
Okay,
whether
So close.
whether-
I think everybody at each team needs to finish the third one. So that's why I brought you guys back so you guys can do it together, okay?
No.
We almost got the answer for the third
All
one.
right,
I think
show me
we
what you
have
got.
the answer.
I
Show
know
me
it
what
is.
you got.
It's 3.66.
That's what-
We got about 3.66 as the
Show me
last
what you got.
what units?
Oh no.
kilometers per second.
Here, Levi, you can
That's
write
not
what
mass,
the
dude.
thing was.
That's not
Kilometers
right.
per
That's
second.
not.
That's
No,
not
it says how
right.
fast is the rocket traveling at the end of the first stage.
Yeah, I
That's
would
the
agree
question.
close to that. I would agree close to
3.66.
that. Okay, I love it.
3.66 what?
Kilograms.
Kilometers per
ah.
second, right?
Kilometers per second, yes.
Okay. All right, so the first one, who wants to explain what you did? Nobody.
I will.
Yeah.
I didn't do the
will.
first one.
Volunteer.
I'm gonna go ahead and let the people who did the first one.
Okay.
Explain.
So we used T equals MA. We found our mass and we converted it to kilograms, which is 5 million. And then we multiplied that by 9.8, our acceleration due to gravity, and we got 49 million newtons.
Okay, so that's how much thrust you need to get this off the ground.
Yes.
That's the minimum amount we need.
Yes, ma'am.
Okay, cool.
So
Number
then-
two.
So then in the second stage, we just divided that out into kilonewtons, and we took the wait. That's supposed to say kilograms. That's on me. And then we took the mass of the rocket, and then we divided that out into meters per second, which I strangely found out that the equivalent of the mass is also the equivalent to 1.13 elephants for no reason. That's just what my calculator showed me.
Okay,
it
so let's make this real simple. The 74,000 kilonewtons, what is that in newtons? What does kilo mean?
1,000.
All right, let's put 3 zeros at the end of that.
74 million. 74 million.
All right,
400,000.
74 million divided by,
400,000 newtons.
and this mass here, now this is the new mass without propellant, right?
Yeah.
Yes.
Okay, so let's see if I can read this. The weight of the rocket with everything else, without propellant, is how much?
It lagged out a little bit. It's 4,535.9 kilograms.
Mm.
Let's think about it.
What do you mean?
Got it. This rocket is starting at 5 million kilograms.
Yeah, I think something bad happened.
Okay, you're taking out the fuel. For time's sake, let's just say it's 45 million left. Or no, sorry. Not 45 million. So it's starting at 5 million and you want to take out 400 I should really look up the number. Let me see my Starship log for fuel here. All right, so you're starting at, oh, that's the first one. Here we go. Minus the mass. All right, it's taking away. Where is my Wikipedia? Starship. Fuel.
Hey Siri.
That's right. Starship propellant. Let's see. Oh, okay. 200 tons. Okay, it actually holds 200 tons, which is about 2 million kilograms of fuel.
What?
So 5 million minus 2 million is
3 million.
all right. That's your new weight.
So
Wow.
So it's 74 million newtons divided by your 3 million. Is that what you guys said?
let me
would
just
be-
pull up my calculator here.
What?
When can I do the Kahoot?
After this.
You're done with all
Miles,
this.
you were
math.
just done. You want out.
Y'all are gonna love my engineering class.
Oh,
Yay!
Math,
I'm
math,
intrigued.
math. All right, what do we get? 74 million divided by, we're just gonna quickly say it's 3 million. I'm sure there's much more precise answers than this.
Looking for
Does anyone-
directionally accurate.
Yeah. 74. 1, 2, 3, 1, 2, 3. I'll do it. Divided by 3. 1, 2, 3, 1, 2, 3. I got around 24 meters per second squared.
We weren't that far off, just by like 8 meters.
8 meters.
I will say this, when I did it more accurately, it was around 60 meters a second. So something around there. Okay. Now that's at max thrust when there's less fuel. You're going pretty darn fast, right, guys?
Yes.
Yeah,
Now, is this lifting? This is definitely lifting off the ground, right?
definitely.
Yes.
Yeah.
Okay, this is definitely lifting off the ground. Now let's see how fast it's actually traveling, right? Like the speed at which this is traveling. All right, this is the end of the first stage. We have these numbers. We know it mass initial. We now know mass final is 3 million. Let's just pull that number out there, right? So that's correct. So we have a 3.21 as the escape velocity. And in your calculator, there should be an LN button
Let's see, 3.2.
for the natural log.
3.21 ln 5 million over 1.6.
Okay. I actually got something a little different, but that's fine.
9.031048401.
3.6 is fine.
Oh,
Good.
natural log.
Yeah. I got around 4, but that's fine. You had 3.66 here, so you weren't too far off, and then 1 point something.
Oh,
So
I
that
missed-
actually makes more sense. All right. So all of those are kilometers per second, right?
Yes.
Okay. So what would that be in meters per second?
Oh no.
Just to add 1,000.
E.
Move that decimal place 3 spots.
3,000.
It would be
36,000.
366. No, that's not right.
66,000.
So close.
3,660.
All right,
There we go.
3,666. All right, now I want to show you guys something real quick.
That's fast.
That's fast.
It's fast.
Not now. Okay, here on.
Yes, really fast.
Well, I do say real quick. I always have to, when I change to my iPad, it's never really quick.
I mean, like if I was just cruising at a couple 100,000 miles an hour, I don't think I'd make it very far.
So that's what I wanted to show you. Okay, so
What's the speed
who
of sound?
knows what the speed of sound?
765 miles per hour.
747 miles per hour.
No.
What is it in
No.
meters per second?
Yeah.
What is it?
I don't know.
Meters per second.
Wow. What's with meters?
300. You guys have computers. What is the speed of
We're-
sound in meters per second?
What was that?
343 meters per second.
343 meters per second.
meters per second.
Wait,
So
what
how
country are
fast
you
is-
guys?
How fast is your rocket going at the end of the first stage?
Fast.
Supersonic.
Something like
We
that?
are going
10
above
times
and
the speed of
beyond
sound?
supersonic.
My gosh.
All right, so what do they call that?
Fast.
Supersonic.
That is where, when you listen to them when they're launching their rocket, halfway, well, a couple seconds through, they'll go, "We have reached supersonic." That's when you are
Oh.
literally going faster than the speed of sound.
Literally going
Everybody
Mach 10.
supersonic racing.
Yeah, so
What-
that's
what's your-
when you get.
What's your question, Eduardo?
I just thought that it depends on the temperature, the speed of sound.
It does, and humidity and a bunch of other things too.
Yep.
It's average at sea level, 343 meters or almost 1,200 feet per second.
You're right. So as
But
soon
you-
as
you are
get to
correct.
So I think that is at like 20 degrees Celsius, 343 if I'm, and then it's different at 0. But
Yep.
yeah, it will change a little bit. But you're definitely going faster than both of those.
Miss Carol,
Yes.
just wanted to know the speed of sound. It's also 1,227 kilometers per hour.
Per hour.
Per hour. Okay, so that's actually a really good point. When you watch these rocket launches, they will have speed or velocity, like a little ticker going
Yeah,
on.
in
so you can
kilometers,
see it change,
and
and
miles per hour,
they will do kilometers an hour.
and
That's right.
sometimes miles per hour.
That's right, depending on where you're watching. Yeah. So that's super fast, right, guys?
Yeah.
Yes.
This is where
Mhm.
you see that awesome little sound dome cloud when it reaches supersonic, and you hear that big boom, and it shakes everything. All right, let's see. I'm gonna stop share now.
Is it Kahoot time,
So
Mother?
team 2, what'd you get?
Oh no.
All right, so now that
Oh,
Starship,
our
what do we
team.
get for Falcon Heavy? We'll go over that real quick since we just did the math here.
Well, we didn't really take a picture at the end,
Oh
but because most of it is written on my paper right here, as you can see.
no. Oh, okay,
So,
awesome.
But the answer we got to our first question was I don't actually know how we did it, but we looked up the mass, like the overall mass of Falcon Heavy, which I think was 1,420,788 kilograms. And
Perfect.
then wait.
You
Oh,
multiply
then
by
we
9.8, right?
yeah, then we multiplied it by 9.8 meters per second squared, or just 9.8. And we got, I think it was, I don't really know. But in the end,
12 million. Around 12 million newtons.
yeah, 12 million newtons.
All right, so
And
that's how much thrust you're gonna need to get that rocket off the ground. So what was the Starship, guys? How many newtons did you need to get that rocket off the ground?
About
lot.
45 million, 49 million.
49 million for one rocket. So one rocket is significantly heavier than the other, isn't it, guys?
Yes.
All right. So now we have acceleration. So this is at the end of the first stage. What did you get for the acceleration of that rocket?
What we did for that, we took the max thrust, which was around 76 million newtons. And we divided it by 700,000, which I think was the mass.
Right.
And
the mass without propellant. Okay.
yeah. And we got 108 mile
All right. So that
meters
was
per second.
accelerating at about 100 meters a second. So now the last bit is, you're right, squared. I keep forgetting. Why do I keep doing that? All right, squared. Acceleration, everybody, if Miss Tara misspeaks, is meters per second squared.
Squared.
All right, my mistakes shouldn't be your mistakes. All right, so now we're going to do the velocity, or the how fast we're going to go. So with that, I know you guys didn't get to the third one, right?
No, we didn't.
Okay. All right, so that one is going to be about, I have about 1.2 kilometers a second. So, which is what? Let's do some more converting. 1.2 kilometers a second to meters a second is what?
1,200 kilometers a second.
All right, we're going to keep practicing these conversions. All right, so 1,200 meters a second. Is that faster than the speed of sound?
Yeah.
Yes. So they're both
Oh,
going
seems a little
pretty darn
close.
fast. All right, so now you know when you watch a rocket launch how they calculate these things. Good job, guys. You are all officially hired at SpaceX.
No, not work.
I'll be fired within
Honestly,
a
I
week.
kind of want to work for Neuralink.
Emma,
What
Gonna
was,
be doing
what
a
was
lot
he
of
looking
different
up on
math.
Wikipedia? How much mass does his rocket have? I forgot.
how'd you get how'd you get hired, Wikipedia?
Well, when you build your own model rockets, you can start making these calculations, can't you?
That's right.
Ooh, fun.
Get
I know,
ready.
but that's solid propellant right there. Solid fuel. All right, who's ready for Kahoot?
Me.
All right, do we want to say
Me.
thank you to Mr. Mike? Or does Mr.
Bye,
Mike want
Mr. Mike. I'm leaving.
Bye, Mr.
Me too.
Math.
Thank you
Me
for your
too, buddy.
help.
I'll
Oh.
follow you.
Bye,
out.
Thank
Mr. Math.
you.
Deuces,
Goodbye,
bro.
Thank you,
Mr. Mike.
Father.
Thank you for helping us.
Anytime. My pleasure. Y'all keep up the good work.
Yes,
thank you.
everyone did. Excellent.
See ya. Bye.
See you.
To put it
Bye.
in perspective, you guys are doing rocket science. I just want you to know that. so
Little.
seems hard. There's a reason why.
Right.
Bye.
All right. See you.
And
The
just like
seeds
that,
to
he's
fill
gone with
out
the
book.
velocity.
So now when your mom gives you all your multiplication and division stuff, you'd be like, yeah, it's not rocket science.
I do not need to do this.
So like
You're right,
algebra's easy.
it's more boring. It's more boring.
Excuse me.
Algebra's super easy.
I'm
Now I
not
can back to
gonna
my
do the
aviation
Kahoot quiz.
now I can brag to my aviation obsessed friend. Be like, yeah, your calculations aren't rocket science.
That's right.
Bye. I'm leaving.
Okay, thank you for joining.
You're welcome.
All right.
Bye.
Well, you guys can comment in the chat. I'm going to find.
Paddington.
According to my
My-
calculations, it's not rocket science.
All right. I mean,
But
you guys
it is.
were definitely
We just did it.
fabulous.
How many puns are we gonna have at the end of this about rocket science?
Of rockets.
All right, let's see. I
Oh,
found my
guys,
Kahoot.
prepare yourselves for the end of semester Kahoot.
Oh, is there an end of semester Kahoot?
I don't know. There was one for science.
Oh, that's actually true for biochem. We did have that. Do you guys want me to do that? Combine all the Kahoots into one big
Yes.
Kahoot?
Yes.
Yes,
Yeah.
yes, yes, yes,
Wait,
yes,
y'all
yes,
did a
yes, 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 yes.
Yay!
I'll re-
Yeah.
yeah,
We did a biochem.
Where
yeah, Emma, I'm reclaiming my
where
old
has this
trophy.
class been all my life?
Nuh-uh.
Uh,
Not on my watch.
Biochem was right before this.
biochem was one before this one.
All right.
We
let's-
were brothers once.
So you were off by
Oh,
maybe a
God.
class.
All right, everybody. 827-837.
You sound like those people on the ads.
Yeah.
Call
Dial the phone
827-837.
Toes.
Toes, I swear, I'm going to get you.
Never.
Wait, what happened with Toes?
Toes
I
was my
wrecked her.
mortal enemy last
I
time.
wrecked her
One of these
very, very
times-
hard.
One of these times we should do something other than normal mode.
I know.
Please,
No,
not.
no, normal
Normal,
mode
to
is
be
fine.
honest.
Normal
You know
mode is
what?
fine, especially with
Classic
rocket
is-
science.
I think we need a poll in our Google Classroom.
Don't be
for this. I
surprised
think
if
it's like
some of
half-
us
Don't pull
go
this.
straight to classic.
Don't pull this. If you pull this, we're gonna go to madness. Democracy is not in our blood.
Democracy. It's going to be a war of politics.
All right.
No
If
let's-
only
politics.
Kahoot.
Let's
All right,
just
is that
fight to the
everybody? I
death
think
like
we
for
got-
this.
13.
Democracy. Law.
Is that everyone? Speak
Yes.
now.
Yeah.
Yeah.
There,
Oh, there you
Next
go.
there we
laws.
go.
Speak
Now that's
for
everyone.
peace.
Okay, I'm beginning.
Okay.
Emma's enemy.
Emma's. Who the heck is Emma's enemy?
Rocket science.
That's
Who
me.
Definitely.
That's me. That's me. That's me. That's me.
No, you're my friend.
Oh,
Frenemies.
Is he
Force
though?
equals.
Force equals.
Force is
Force.
That was quick.
Equals
May
force
the
is
force be with
force.
you.
Obi-Wan
Force is
Kenobi.
force.
Force is force.
Force
It
is
is.
force and force is force and force
Also,
is
they're never gonna move
force
that
is
rock.
force.
Uh-oh, did I click wrong?
Who the
Did I
heck
do
drew
something?
on the screen?
I think
Wait,
I
what,
think
what
someone.
did Apple say?
Oh, hey, I was right. Haha.
Oh, I'm on the
Hey,
podium.
I was like, haha.
I'm in second place.
Do you vote in English?
The Newton dollar.
No, he
Yes.
voted last time.
The
One of a
oh, yes,
kind.
the dollar.
The dollar.
The dollar.
The
Wow.
dollar.
But no.
Phil actually got 1,000 points.
Oh my god. You were the first to answer.
Breakfast rolls.
Breakfast
Oh my
rolls.
gosh.
Are those breakfast
No,
rolls?
no,
Those
exactly.
are fig
Kevin,
bars.
breakfast.
Big
Those are
Newton.
fig bars, guys.
Those are fig Newtons.
It's the rolls.
Big
Oh, they are fig Newtons. I get it now.
Who is Toad?
I'm 3 points behind
That would be
Edgewater.
me. That would be me.
Corey.
The mass will be
Infinite.
infinite.
Infinity.
It never ends.
No, 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 no.
It's that endless mass.
Endless mass is just existence.
So keep in the second place.
Oh my gosh, how did I get to 11th place?
No, what
What
is your
is
math?
this?
You get one thing wrong, you're all the way at the bottom.
Exactly.
Tara, don't give us questions like this.
It's on. It's in the book.
Hey, if you
It's in
did the
book.
reading, you should know.
Emma, what is your mass?
I'm gonna go to the
Oh
bathroom.
man.
Oh, I'm probably
That's-
100 pounds. I am probably 100 pounds. I'm big. No.
It's obviously, bro. It's
Newtons?
obviously.
Newt?
It's acceleration.
I don't know.
Acceleration.
I got it right.
Play. Yes.
This is incorrect grammar.
I think that's. I
Well,
think that's
I
what.
Poor
pray for that
guy. I
man.
think
He
he was just getting
survived.
ready to go to his business meeting and he's
Yeah.
My
flying
guy
this
fell off
guy
of
now.
a
And he
plane.
fell out
My
of
guy
a
fell off
plane.
of a plane.
Oh,
There's
He was
ooh, what's
flying.
that
To,
down
bro, he was
there?
flying to LA. And he
Who is
fell off the
Hiva?
plane.
Who is Hiva?
increasing
I'm going to
acceleration,
Hiva.
force, broke.
Ah.
Oh no, did I click wrong?
Does increasing
I spam clicked
acceleration
because it
Very,
wasn't
increase
loading.
force?
I don't even know what I answered.
Yes,
Spam.
I
click.
think.
I don't even know what. Oh my gosh, I got it right.
Yeah.
It's
Let's
funny
go.
whenever everyone gets it wrong because they put it on the wrong because the things are switched. True and false are switched.
Mm.
It is
What?
called the
It's
corner
called center
gravity.
of gravity. The center of gravity is twice. I don't know why they put that like that.
The corner
Wait,
of
so but
gravity.
which center of gravity?
Wait,
There
but
are
there's
two
two center of
types
gravity.
Of
It's not the
centers
center of
gravities.
gravity. Because it's
Which
not the center of
center?
gravity.
The Earth has more inertia than the moon.
False.
That is a weird Earth.
False. It's super false.
Guys, it's obviously false.
It's obviously.
Ew.
Is that made out of clay?
It would be impressive.
I think it's floating. Yeah, it's floating. I think
That
it's how
we're in physics. How dare you say that
Floating
while
in
we're in
space.
physics class?
Yay.
Ooh, select.
It never
What?
works.
a little in gravitational.
Okay.
Your pair of legs. Pair.
Pairs. There's literally pairs.
They're just pairs.
A pair of what?
Pairs.
Pair,
Pair
pair,
of
pair.
pairs.
Pair,
Pair of
pair.
pairs.
A pair of pairs.
No, it's a pair of pairs.
Partially correct. I answered correct.
Partially.
I answered both of them. Oh my god.
Making
Contact
friends with
lenses.
aliens.
The contact lenses.
Hey, this
Making
is false. You
friends
should
with
never have
aliens.
mascara on when you're putting contacts in.
Do
Why?
you speak from experience, Lola?
Yes, I do, Emma. Yes, I do.
And what, pray tell, happens when you put contact lenses on with mascara?
Well, then the mascara gets on the contact lenses, and then you have mascara in your eye for the rest of the day.
Oh.
Dirt.
Why
It's
is
it-
it's dirt.
No!
It's dirt. It's
No,
dirt.
I clicked it wrong. Oh wait, no, I didn't. I thought I clicked the blue one.
No. No.
Levi passed you.
Car crash.
Oh. Why are you laughing?
That was so violent.
Oh, dang.
Just whoa, a car crash.
Oh, car crash.
Why is it Lee Calling Agent instead of Lee Clothing Agent for the name?
I misspelled it. It's a typo.
Davini.
Davini.
I am the one who
Davini.
suggested it.
Me.
It's
I was
always
about to have a heart
Davini.
attack because I had to look for the whole book. But then I realized there's only one reasonable answer.
Davini.
Is
That's
the
hilarious.
constellation of momentum?
Momentum at its finest.
It's always the most
Momentum
complicated
at its
answer.
finest.
That's what I know. It's
Well,
always the most
sometimes it's not.
complicated
Dang
answer.
it. Oh my
Not
gosh.
always.
Momentum at its finest.
back on top,
There's 32 questions, Emily. You better stay on top.
climbing up the ladder of points.
You're
Sanity?
Your sanity.
Your sanity.
Our sanity is
Oh
conserved.
no! Oh no! Oh no!
I don't know which one I clicked.
Oh,
I
no.
just clicked.
Joe
I
Sweet.
clicked the
Hey, I
Yeah,
got it
the
right.
right one.
Oh hey, I'm in the leaderboard. Finally, I'm
Well,
on
I have
the
an answer
leaderboard.
streak too. Elasticity.
Friction.
Elasticity. Friction.
I'm about to go all the way to 11. Watch me.
From the very top, too.
Fourth. Okay.
I'm in 11th place behind the
I'm
kid.
still disappointed.
Contact.
Contact.
Thank you for giving us the answer.
Man.
Thank you for
Wait,
giving us
what?
the answer.
Why did
Magnetic
it-
forces.
What is going on in the picture?
I think
I
he
did that
fell
once.
in.
I ended up breaking my
So-
opposite Lego.
Bro was in the VR, didn't see the box.
He's determined.
The rocket.
Funny.
Equation.
Calculates the food.
Calculates the
Calculates
food
the
needed
food
to
needed
achieve
to achieve
orbit.
orbit.
I think I clicked it wrong.
It calculates everything needed to achieve happiness.
Yay.
Oh, I'm off the leaderboard now.
Who created the classical rocket equation?
Oh, dang.
Oppenheimer.
Von Neumann. Guys, stay
Oppenheimer.
Everybody in
Oppenheimer.
Russian.
2-person.
Everyone says a
And
long
now I
answer, but
become
everyone
deaf.
gets it right.
And now
I
destroy
all right,
your
I'm
order.
lucky. I totally thought my finger slipped between
Back in third.
red and yellow.
And now I have become death. Destroyer of worlds.
Oh.
What Oppenheimer said.
That Jim Carrey?
Variable effects.
I don't think he'd be I don't think he'd feel
It's,
too well if he actually was on a rocket.
It's the size and fin design.
What variables affect a rocket? Love, I guess.
Love,
I mean,
power, friendship,
Volume and
hopes and
pressure.
dreams.
Let's see.
That's a funny video.
We're gonna have to wait the 20 seconds for it to finish loading.
Oh no.
Oh.
Yay!
Yay! I got it correct.
Yay. I'm in
Oh, I got it incorrect.
place. Wow.
What country are some of you in?
It's the fourth one.
it's the fourth one, guys.
The one, duh.
Or even
Dude has 4 lots of motion.
the
No one
fourth
knows
one.
the fourth one though.
Okay.
Guys, I have an answer streak of 1.
How does that count as a streak?
Increases from 0.
Blows up the
Blows up
rocket.
the rocket.
Oh my gosh,
Oh,
my
yeah.
laptop just
Keeps
closed.
blowing up.
Yeah, bro, you see it
Up
right
the
there.
rocket. Oof. Goes the camera. Oof goes the camera, guys. The smoke hits.
We'd like to take a moment to be
And
all our food keeps blowing up.
rocket engine, let's talk.
We're almost there, guys. Rocket engine, just the rocket engine.
Matter and energy are illusions. Okay, if you
We're
say.
living in a simulation. Reality is an illusion. Buy gold. Bye.
I chose the wrong one.
Oh yeah, fourth place. Yoo-hoo.
The Starship
The
rocket
Starship
was what?
rocket was.
I don't know.
I don't
Shoot,
know
shoot, shoot,
either.
shoot, 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 shoot.
Oh, I picked the
No,
wrong
no,
one.
no, 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 no.
100%.
No, 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 no.
I
no.
accidentally
I
left.
picked green.
Please tell me. Please tell me. Please.
Emma,
Please.
when you do that,
Please.
you sound like an Awuga horn.
Most powerful. Most powerful.
Whoop.
Most powerful.
Guys,
Wait,
somehow my
wait.
laptop
I don't know
closed
the
and I
leaderboard yet.
left.
Oh.
Oh no.
Charger rocket green.
It's
Oh,
one
this is
Wait,
why-
we
kilogram.
know this.
There. Okay.
I'm
Guys,
sorry
wait,
for
we
everyone
know
who wasn't in the
this.
Starship. I'm sorry for everyone who wasn't in the Starship group.
Was it this one?
Hehe.
Sound like
Oh
an
wait, how we
Awuga
gonna?
horn?
The next question
Yeah,
is probably
when he
gonna
goes-
be what's the weight of Falcon Heavy?
When she does that, when she yeah, that.
I don't
Wait,
hear
wait, wait,
crap.
Emma, the
You
next
say
question is
no,
probably gonna be
you
what's the
say
weight of Falcon Heavy?
Guys, how am I still in 10th place?
Am I still
been in
there?
10th
I
place
know, right?
for like 17 rounds.
Beans.
Decompose
beans.
matter.
Beans.
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 Oh, I
Beans.
clicked the wrong thing.
Beans.
I misclicked.
That's
Guys,
Yo,
I'm
that's
about
the
to let out the
future.
most ambitious
Everyone got the
beans
correct
ever.
answer, even the
Oh,
people
no.
didn't.
Guys,
Oh,
Points.
man.
Falcon Heavy
What?
3 is Falcon 9.
Falcon has
Three Falcon
What?
9s.
Bird.
It's a falcon.
Maybe.
Nabby.
No. Yes.
It's Mabby.
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 Bye bye.
Bye.
It's
Mabby.
bye
Bye.
Hypo.
Bye.
Bye.
And Mabby.
bye.
I don't like how this question.
Oh, I'm in 9th place. Let's go.
I was thinking of the Starship.
I can't get
Yeah.
this wrong.
Question. Oh my gosh. Oh my gosh.
This is fun.
What?
Has a lock.
How?
Didn't-
How? What is?
The
Miss
next
Tara, you are sick.
All
Miss
right.
Tara?
One.
Wait, I
one-
wanna switch time.
You sicko.
You
Tara,
didn't
you
give
are
us a good time
sick.
to answer
Okay,
this.
All right,
hold on.
remember, one for us, one's one direction, one's the other direction. So the
Shoot,
net
shoot,
is the
shoot, shoot, shoot,
difference
shoot,
between
shoot.
the two.
The answer is chicken nuggets.
Bro.
I agree with that answer.
Levi, it's just the difference in it. Just
Dang
gotta
it.
subtract
What
it.
place did I get?
I got it
It
correct.
should tell you.
It doesn't tell me.
Second.
That frog
Oh.
is going. Oh, they're both glitching out.
Oh, bye-bye.
Everyone else see them glitching?
Amazing. Amazing.
I must have gotten like 6th place.
I
or something.
won Emma.
Knowledge powerhouse.
Good job.
Emma, you're
guys.
frozen.
Okay.
I'm not frozen.
Yeah, you are.
Let it go.
Oh,
Okay,
I
what
am.
did we learn
Wait.
from this,
There we
guys?
go.
Yeah, what
had-
did we learn from this?
I
What did
had
we
like
Have you seen
50
Frozen?
something points to stay in
I've
first
seen
place.
both movies.
We learned that the moment you misclick anything, you're at last place.
We
Right.
also
Found
learned that
16th
Yeah.
ago.
we also learned that if you accidentally close your laptop, it will log you out of the Zoom meeting.
Oh.
That's kind of critical to the meeting. So yes, that's
Yeah.
an important lesson to me.
Oh yeah, but Emma, I was scared. I had but 50 something points to
Oh.
stay in first.
Ooh.
I
Levi.
came so close. I came so close.
You. Who were
I came
you?
so close. I was
Emma.
iPhone.
Emma, Levi is frightened by
I
you.
was like 7th place.
Levi is scared
Emma's
of you.
looking for
7th place
revenge.
is on thing.
Oh, where'd she go?
You.
All right, good job, everybody. That is
you.
that is
You
class.
did it. You.
If anybody has anything else to share, we're done. You
I
are
have nothing
done.
else to
I've come
share.
reclaim my throne.
Are we
I've come to
doing
reclaim my
the-
throne.
Are we doing the coding class?
If you guys would like to do the coding class, we can continue it, sure.
No.
Emma.
Wait, what?
Emma is just
She's mad. She's like really mad.
I love
Don't
how the
have
camera is
the-
like
Revenge.
This isn't good.
All right, Mr. Miles, you can stop the recording.
Yes.